Good evening, all. So, this is the third week of the lectures of the course Wastewater Treatment and Recycling. So, my name is Mansi Tripathi. I am the TA for this course from IIT Madras. So, this third week was all about water quality parameters. So, in short, there are three types of water quality parameters: physical, chemical, and biological. When we talk about physical water quality parameters, these are those parameters that we can touch or see. So that will be like, for example, temperature, turbidity, pH, and all. And when we talk about chemical water quality parameters, these are the water quality parameters that we can measure chemically. Okay, so for example, acidity, alkalinity, hardness, all these things. Coming to biological water quality parameters, these are related to the microorganisms present in water. For example, fecal coliform, total coliforms, all these things. So, among all these three parameters, biological water quality parameter is more important. So, among all these three parameters that I was talking about, biological water quality parameter is more important because it is directly related to the disease that our body can have if we consume a very small amount of any contaminated water, because these microorganisms tend to multiply in our body. That is why among all the water quality parameters, we should take care of biological water quality parameters more. So this was in very short about all three water quality parameters. So what was that? What were there? Physical, chemical, and biological. So sir has talked about all these things in very detail in his lecture. So we'll solve some of the example problems in this session. Okay, so I'll share my screen, then we'll solve the problems. So we are entering in the third week. So before starting the question, I'll share one more thing. I'm starting something called poll. I hope you can see this in the right bottom corner of your screen in activities tab. So there will be like question number 1 and option A, B, C, D. If you can see this poll, then you can answer here. If not, you can answer in the chat box also, no problem. Can anyone confirm if they can see these polls?
Yes.
Okay, thank you, Krishna. So it will be better if you answer here, but if there is no problem in answering in the chat box. So the first question is, the color in water can be indirectly measured through solution pH using pH meter, absorbance using spectrophotometer, weight analysis using gravimetric methods, or all of the above. So as I've already told, color is physical water quality parameters that we can see and touch. And color is also very important water quality parameters. Like if we have two glasses of water, one is white having some cyanide, one is yellow having no difficulty. But what water we will prefer? We will think the water which is clear, which is transparent is good, but it has cyanide. No, it can kill us, but still we will prefer that water. So that is why at any cost we should maintain the good color of the water. It can give us some psychological sickness too. Psychological sickness in the sense, we after drinking little colored water, we will think that we will be sick, but actually We are not. So it's all in mind. But color can affect all those things. That is why it is one of the first thing that we as a layman we see in water. So answer this question. Okay, so we'll see the answer now. One of you has answered D. So that one is not correct because color cannot be measured using pH. Okay, what do we measure from pH? How much water is acidic or alkaline? These things we measure using pH. And weight analysis, we measure the particle that is present in that water. So the correct answer is B. Absorbance using spectrophotometer. Looking at the option B, spectrophotometer, we talk about spectrum. Spectrum is mostly related to colors. Okay, so that is how you can answer the question. So now I'm releasing question number 2. Those who have just joined, you can see the question as well as in activities tab in the lower right corner of your screen. You can see the polls in which you can answer the question. It's in the lower right corner of your screen in the activities tab. If you are unable to see that, you can directly answer in the chat box. I hope all of you can see. I received just only one answer. The process of measuring turbidity through which the intensity of light scattered at 90 degree is measured. Here important point is 90 degree. If there is any water column, if the light in this intensity is falling, and if we are measuring from here, then it is we are measuring at 180 degree. Different instrument will be used for this purpose, and if we are measuring in this direction, if we are measuring in this direction, then different technique will be used. So the question is asking about this area. What instrument will be used, what process will be used to measure scattering at the 90 degree? More answers please. We are measuring at 90 degree, not 180 degree. Okay, let's see the answer. Yes, most of you have answered correctly. The solution is A, nephelophotometry. And if we are measuring at 180 degree, then the instrument will be B, turbidity metry, as well as C, spectrophotometry. These instruments B and C, they measure light intensity as 180 degree, 180 degree, and only nephelometry measured light intensity at 90 degrees of the sample. Okay. So moving towards next question. This is question number 3, and I hope you can see the polls for question number 3 as well. Emerging pollutants. Emerging pollutants means two definitions, two important terms are there in emerging pollutant. One is the pollutant is very novel, means new. Okay. And the second important point is it is present in very small quantity. In microgram or nanogram level. So these are two very important points for emerging pollutants. So keeping these 2 points in mind, you can answer what are emerging pollutants. metals such as iron, manganese, and arsenic, pharmaceutical and personal care products, organic effluent from the kitchen, or all of the above. You should be very clear about the definitions. So, just to test the definition skill, we are talking about this question. Yes, more answers, please. Very few people are answering.
Ma'am, all of them.
You can answer the question in the polls. If you are unable to see the poll, you can answer in the chat box. Poll is present at the right bottom corner of your screen in the activities tab. Okay, we'll see the answer. Answer is B. Okay, those who were saying all of the above, organic effluent from kitchen is not new thing, and it is also not present in small quantity. It is present in big quantity. What we get from kitchen, many organic pollutants like uh, uh, fruit slices, vegetables, all these things, surf. So these are not present in small quantity, and these are present in our water since the beginning of time. From the very first day man started making food, these organic effluents are being released from the kitchen. So these are not new. Pharmaceutical and personal care products is the answer, because first of all it is a new thing. uh, New thing, it means that we recently recognized it as a pollutant, and it is present in very small quantity. It is not present everywhere. It is present in some areas in very small quantity. Okay. Moving towards next question. Which of the following causes temporary hardness of water? And these are the poles for it. You can find the poles in the right bottom corner of the screen. This is for the people who have joined just now. There is a poll running and the questions, you can answer them in the polls. So hardness are of two types, temporary hardness and the permanent hardness. Temporary hardness can be easily removed. You must have seen when you boil the water, you see some white precipitate around the utensils. So this is the temporary hardness. But the permanent hardness remains inside the water. It is not precipitated. We need to follow some different chemical or biological means to remove those hardness, mostly chemical. Okay, so you need to answer which four of these is the temporary hardness: magnesium sulfate, calcium chloride, calcium bicarbonate, or magnesium chloride. Yes, more answers. Okay, so hardness is temporary as well as permanent. Temporary hardness is due to carbonates, bicarbonates, and permanent hardness is due to chlorides, sulfate, phosphates, sulfide, and many more. Okay, and hardness are caused by mostly in water by calcium 2 plus and magnesium 2 plus. I hope this will help you to answer the questions. You can correct your answer if you have answered wrongly. Yes. Thank you, Vishakha. Okay. So we'll see the answer. So the solution is C. You need to remember this. Hardness is from the bivalent calcium and magnesium, and this is the definition for temporary and permanent hardness. Okay. So I hope you understood this concept. This you need to remember. This is the next question, and these are the poles for the question number 5. A Roy, you can see the poles. It is in the lower right corner of your screen. You can answer in polls also. If you are unable to find the polls, then you can answer in the chat box, no problem. But try to answer in the polls. It will give us the overall picture. So the question is, dissolved oxygen can be consumed in a stream by photosynthesis, decomposition of organic matter, atmospheric phase transfer, or all of the above. Here we are talking about oxygen consumption. In this question, we are talking about oxygen consumption. So please keep that in mind. Not oxygen production. We are talking about oxygen consumption. One of these three processes is producing oxygen. So keep that in mind. This is a stream. Here we have some dissolved oxygen. So how this dissolved oxygen is consumed? Okay, let's see the answer. So the solution is B, decomposition of organic matter. Those those who have answered D, actually most of you have answered D. So I'll tell you, this is the process of photosynthesis. Photosynthesis is the process by which plants make their food. When plants make their food now, they consume carbon dioxide and release oxygen. So photosynthesis is the process of oxygen release, not consumption. Okay? And atmospheric phase transfer, sometimes oxygen goes and sometimes it comes. Okay, so we cannot really say that the phase transfer is actually oxygen consumption process. It can be oxygen releasing or it can be oxygen generating. Okay, but decomposition of organic matter is always the process for oxygen consumption. Means we are talking about BOD, biochemical oxygen demand. Oxygen consumed by the organic matter present in water. Okay, so we'll move to our next question. Which of the following statement is not true regarding dissolved oxygen? And these are the polls for question number 6. This question is related to the previous one. A. Cold water holds more oxygen than warm water. Here we are talking about the dependence, the solubility of gas in water with respect to temperature. B is in surface water bodies, photosynthesis activities may lead to variations in DO. Photosynthesis, I just told you, process of dissolved oxygen release. They generate oxygen. C, water holds more oxygen at higher altitudes. What happens in higher altitude? There is temperature decrease and pressure also decrease. So we need to check the solubility of gases with respect to temperature and pressure. D. In larger, deeper rivers, some vertical stratification of DO might occur. What is vertical stratification? Just imagine this is a lake and there will be different DO value in different layers of the lake. Okay, so this is stratification. So try to answer this question. We are talking about the statement which is not true. Okay, we'll see the answer. Answer is C. Water holds more oxygen at higher altitudes. So option A is true because if there is some water, if we increase the temperature, so oxygen will go away. Oxygen will bubble out. So yes, cold water holds more oxygen because it has less temperature. This one is true. B. In surface water bodies, photosynthesis activities may lead to early variation in DO. Means in the daytime there will be photosynthesis. So for example, if there is a water body, it has oxygen content of 3 milligram per liter. But if there are plants, they will do photosynthesis, they will release oxygen. So at the end of the day, means in 3-4 hours, the oxygen can be 4 to 5 milligram per liter. So this is also correct. D. In larger and deeper reservoirs, some vertical stratification of DO might occur. So this is a fact that in very large and deep reservoir, we have difference in the DO value. For example, here there will be on the surface there will be some atmospheric transfer. So maybe DO is 5 mg per liter, and in the downward side there will be some floating plants also. So they will do photosynthesis and create oxygen. In the bottom side there will be lesser DO because first of all there will be no phase transfer, no atmospheric reaeration from the atmosphere to the bottom layer. Second, there will be some organisms, they may consume oxygen, that's why there is less oxygen. So overall in this range there will be difference in oxygen. So yes, this equation, this point is also true. Coming to C, yes, water has lower temperature, means water may hold oxygen, but pressure is also low. When there is low pressure, oxygen will come out. Like if you want to dissolve any gas in water, what we do, we try to increase the pressure. When we increase the pressure, the gas gets dissolved in water. But when we decrease the pressure, gas may come out of water. So dissolved oxygen will be very less. So at higher altitude, pressure effect is more than the temperature effect. Okay, that is why this statement is wrong. If there is any doubt, you can ask in between. Okay, or you can ask in the chat box. So this is the next question, and these are the polls for question number 7. Match the instrument or method to the respective water quality parameters. Nephelometer, we have just discussed it. Wrinkler's method, MPN test, and atomic absorption spectra. That is AAS. So what instrument we use to measure what? So you need, this is the kind of match the following. So we are talking about dissolved oxygen, pathogens, metal and turbidity. Try to answer this question. Only 2 people have answered yes. Good. Try to answer this question. Okay. So we have already seen that nephelophotometer is measuring turbidity at the angle of 90 degree. Okay. Wrinkler's method is used for the calculation of dissolved oxygen. We acidify the sample and we measure dissolved oxygen. MPN test, the full form is most probable number. So whenever we count anything in numbers na, we measure pathogens or any biological contaminant. Whenever we talk about number, it's mostly related to the pathogens. Pathogens means disease causing organisms, microorganisms. Fourth is atomic adsorption spectra. So this instrument is used to measure metals. Okay. So 1D, 2A, 3B and 4C. So this is the correct.
Option C.
Yes. So solution C. Nephelometer for turbidity, wrinklers for dissolved oxygen, MPN for bacterial counts, and AAS for presence of metal in water sample. Okay. This is now question number 8, and I am launching poll for question number 8. I hope you can see the poll. Which of the following statement is true for nitrogenous BOD? So BOD is of two types. When we talk about total BOD or ultimate BOD, it comprises of carbonaceous BOD plus nitrogenous BOD. So we are asking question about the nitrogenous BOD. Nitrifiers have slower growth rate. The ultimate BOD of a sample is determined by subtracting NBOD from CBOD. For option B, you can check this statement that I have written. C. Generally, nitrifiers do not flourish until food supply for heterotrophic microbes has diminished. This is very important, point C. And option D is both A and C. Try to answer this question. Only 2 votes. You want to see the poll result? Only 2 of you have answered. I hope you can see the poll results now. Yes? More answers? Others? I think we are 10 and only 6 votes. What about rest 4 people? Okay, we'll see the result now. So the solution is D, means 4 out of 6 people are correct. Now 5. So nitrifiers have slower growth rate because you have seen the BOD curve. BOD curve is like this. So this is CBOD and this is NBOD. This is time axis and this is BOD, means oxygen demand. Okay, so because a nitrogenous BOD, these are autotrophs. The nitrifiers means the organisms that converts that converts ammonia to nitrate are autotrophs. So autotrophs are slow. That is why nitrifiers have slower growth rate, because they are autotrophs and the microorganisms that consume on CBOD are heterotrophs. I hope you know the difference between autotrophs and heterotrophs. Um, anyone of you can answer in the chat box the difference between autotrophs and heterotrophs. So, autotrophs are slower. B is ultimate BOD of the sample determined by subtracting NBOD and CBOD. No, we need to add them. Then only we'll get ultimate BOD. And C is generally nitrifiers do not flourish until food supply for heterotrophic microbes has been diminished. So you can see from this graph also that first we talking about CBOD. So when the carbonaceous are diminished, then only NBOD takes place almost after the 5th or 6th day, not before that. Okay, good, good, Praveen.
Yes.
Okay, let's see the next question. This is question number 9. And this is the poll for question number 9. You can see the poll's result as well. So we need to match the following water quality parameters to their units. So there are some situation where you will just get the unit. So you may have to decide what water quality parameters it is representing. So BOD, turbidity and alkalinity. One is measured in NTU, means nephelometric turbidity unit, milligram per liter, and milligram per liter as calcium carbonate. I think I have answered one of these points. This is 111A, but you can think it is 123 and ABC. There is mistake in making the table. Okay, we'll see the answer now. Yes, all of you are correct. So solution is C, BOD in milligram per liter, turbidity in nephelometric turbidity unit, as the name represents. One more unit we use for turbidity is formazine turbidity unit. Okay, just because in nephelometric instrument we use formazine polymer, that's why we also call it formazine turbidity unit. Okay, this is also the same unit. NTU is equal to FTU, no change, and alkalinity as calcium carbonate. So moving towards next question, question number 10, and these are the polls for question number 10, and you can see the result as well. BOD by CAD ratio of wastewater sample will be usually think whenever we talk about BOD, we talk about biodegradable organic matter. Okay, but when we talk about COD, we talk about biodegradable plus non-biodegradable organic matter. So ultimately, you can see from this statement also that COD will always be greater than BOD. In BOD, it's like very easily soluble material, like carbohydrates will be there, some proteins will be there. But when we talk about COD, we have, apart from these carbohydrates, proteins, we have fats as well as some high oxygen demanding material, like we may have some sulfides that can be converted to sulfate. Also, like anything, any chemical, any metal, metalloid, all those things will be there. They may also get oxidized when we talk about COD. These comes under non-biodegradable organic matter. That is why COD is always greater than POD. So one extra information, when we do COD test, these rings means phenolic compounds, benzene ring, phenolic compounds. These compounds are not oxidized. So if these compounds are present in water, there will be only if these compounds are present, COD won't come. Okay. So we need special method to digest these compounds. These are also degradable compounds, organic compounds, but we won't get anything if we do COD analysis. Okay, so this is some extra information. It will be good if you remember. So the solution is B.
Uh, could you please
Yeah.
elaborate again, ma'am?
About this phenolic compound thing.
Yes, 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 ma'am.
Okay, so I was saying that there are many compounds that this COD, how do we do COD test? We take the organic material, we acidify that particular, we acidify the area and we increase the temperature. Like for 2 hours, we will put H2SO4, that is sulfuric acid, to digest the sample, okay, at very high temperature and in very acidic condition. So what do? We digest all the organic matter into inorganic form like carbon dioxide, water. In these form we try to digest. But
Okay, okay.
if there are any organic compound having the ring structure, okay, we
Ma'am.
cannot digest this. These are very highly resistant compound. They can tolerate high temperature and they can tolerate highly acidic condition also. So they will
Okay,
be as it is. So even COD test cannot give oxygen demands for these compounds. But these compounds also need oxygen. They also consume oxygen. So there are various high techniques, high quality measurements, high quality instruments are there that measure oxygen demand for these compounds. COD is very small in front of this compound. Okay, that's what I was saying.
thank you, ma'am.
Oh, thank you. So we'll see the next question. So the answer was B. This is question number 11 and these are the polls for question number 11. So this is more about the gravimetric techniques. Gravimetric techniques means we try to measure the weight. So how do we measure these weights? Like what are these column 1 represents? Okay. So when we talk about total solids, there are dissolved solids plus suspended solids. Okay. This is first step. Now, in dissolved solid as well as suspended solids, we have fixed solids plus volatile solids. In suspended also, we have fixed solids plus volatile solids. Okay. So, this is the kind of table you can remember. When we talk about fixed solids, so at the temperature of 550 degrees Celsius, 500 to 600 degrees Celsius, there will be no change in fixed solids. But all the volatile solids will go. It will be evaporated at the temperature of 500 to 600. Same goes with these two. Fixed solids, they can retain 500 degrees Celsius. but the volatile can't. Okay, so you can try to answer this question. You want to see the result? Yeah, this is, so it's very diverse. You can answer this question. First of all, you need to know all these particles are in dissolved forms or in suspended form. So you can differentiate first suspended and dissolved thing, then go inside fixed or volatile. This is the trick to solve the question. First check if these solids are suspended or dissolved. Dissolved, you cannot see them from your naked eyes, but suspended you can see if they are in very large amount. And dissolved, whatever the amount is, very large, very less, you won't be able to see them. Okay, so I think those of you who always answers have already answered, so we'll see the solution. So the solution is B. See, first of all we will divide it into suspended and dissolved. So starting from the fourth, so silt particle. Okay, so silt particle means it is dust and all, so you can see these particles. So first of all it's fixed that it is suspended. Okay, it's not dissolved, it's suspended, so either B or D. Okay, so the second point is we will check it is volatile or not. So if you increase the temperature, soil won't evaporate, soil will still be there. Okay, silt is soil, so 4 to B. This one is fixed. Second is sugar and fatty acids. So fatty acids and sugar, these when you will dissolve, you won't be able to see this. Okay, so these will be dissolved. This one is fixed, either A or C. Now when you will put this in 500 degrees Celsius, what will happen? So they will be evaporated. You won't find a trace at that high temperature. So that is why C will go with 3. There it's like it's 2, 3, 4. A, B, C, D. So microorganisms, when there are like, yes, you cannot see microorganisms with your naked eyes, but when they are large in number in water, you can clearly see the yellow tint or the green tint. So when you can see the tint, it is always suspended. And when you will put the microorganisms at 500 degrees Celsius, it will go away. So that is why microorganisms are volatile suspended solids. Next is inorganic salts. So this is fixed dissolved solids. Okay. Moving towards next question. Question number 12. And these are the poles for question number 12. So you can use your calculators for this. Try to solve this question. The volume of water is 100 ml, and the water is filtered through glass fiber type C filter. This is glass fiber filter. It has very small pores. Okay, it's filter. So filter weight W1, you can say this is filter weight. This is 2.4 grams, and filter rate collected in a crucible of weight 23.50 gram. So W1 is filter weight. Note down every point. Okay, now crucible weight. Crucible weight is 23 0.50 grams, W2. Now after oven drying at 104 degrees Celsius for 24 hours, the resultant dried weight of filter was 2.456. So filter weight plus the sample weight was 2.465 grams. Because they are drying the filter paper itself with the sample. And dried weight of crucible means crucible plus sample crucible plus sample is equal to 25.10 grams. So we need to find the total suspended solids. So first of all, I told you what is suspended solid that you can see from your naked eye, that is not dissolved. So one thing is fixed, the solids, when we filter it, it won't go inside the water. It will remain on the filter paper. So we will take care of these two only. We will take care of filter and the filter plus sample. Okay. So how we will measure total suspended solids? Total suspended solids is equal to W3 minus W1 divided by volume. Okay. So we'll see the answer. So answer is A, 650 milligram per liter. See, W3 minus W1 divided by volume, 2.465 minus 2.4, and the answer is in milligrams per liter and this was in gram. So we will multiply it by 1000. So gram is converted to milligram and it is in liter. So ml will be converted to liter. So 100 ml is equal to 0.1 liter. When we will solve, we will get 650 milligrams per liter. We can check. Yes, it's coming 650 milligrams per liter. All of you got the answer? I hope you understood how we are getting this answer. And please note down all the parameters because next question is based on this statement only. Question number 13 is from this statement only. Okay, we'll move towards next question then. So what would be the concentration of total dissolved solids? Total dissolved solids means the solids which entered inside the water. It has passed through the filter paper. Now it's in the crucible. So how we will do? Weight of crucible plus solid minus the weight of the crucible divided by the volume of water in liter, and this weight in milligrams. So solve this question. Sit with calculators, okay? From the next time, there will be more of numericals, less of theory. So please be there with calculators all the time. Okay, we'll see the answer now. So the solution is B. Yes, 3 of you have answered and the answer is correct. So this is how we'll do it. Rest of the people, you found the answer? Try to solve on your own. If there is any doubt, you can ask in between.
Ma'am, this recorded lecture will be available since I script the lecture actually.
Yes, yes, yes. It will be available. You will get the material as well as the recording.
Okay, ma'am. Thank you, ma'am.
Okay, thank you. I think one person has answered D. You please check the solution. And in case of doubt, you can ask. Okay, moving towards next question. This is question number 14. And the polls for question number 14 are now open. Which of the following is false for fecal coliform bacteria? So, as I have told you in the very initial time, there are three kinds of water quality parameters: physical, chemical, and biological. So, biological water quality parameters are more important because it's directly related to the disease and illness that can be caused in human as well as animal as well as in plants. So, fecal coliform bacteria we are measuring. Fecal coliform bacteria means the coliform bacteria that are present in the feces. They are indicators for fecal contamination of water. All of them are pathogenic in nature. Microbiologically contaminated water will exhibit the presence of large number of FCB, fecal coliform bacteria, or none of the above. Try to answer this question. We'll see the answer. Solution is B. So this is the false. We measure, see, when we want to measure the pathogens inside water, we measure the indicators. We never measure the pathogens. There are three reasons. First, the pathogens present are very less. It cannot be counted easily. And the second and the most important reason is we we will not touch pathogens by our hand. We don't want that disease. Okay, so we try to avoid the pathogens. We will not take the pathogens in our labs, that so that we will get ill and the other people working on our lab get ill. So we avoid pathogens. So this is the false statement. We measure fecal coliform bacteria just because they are non-pathogenic, but they are good indicator of the pathogenic bacteria, because wherever there is pathogenic bacteria, these fecal coliform bacteria will be present. Okay, if there is water in which there were in like 1 month back there was some pathogens, even now we will find the fecal, even if the pathogens are gone, okay, we will still find the fecal coliform bacteria. Okay, we never measure the pathogens directly because we are feared of the disease. So moving towards the last question, this is also a numerical type question. The theoretical oxygen of benzoic acid takes place in the following reaction. So this is the reaction for wastewater containing 370 ppm of, ppm means milligrams per liter of benzoic acid. Estimate theoretical COD value. We need to find out the amount of oxygen that will be present. First of all, note down this equation, then find the molar mass of benzoic acid as well as molar mass of oxygen. I will do with you, but you try to solve on your own. Plus 15 O2. What is the molar mass of benzoic acid? Anyone please calculate? I found this on internet. Please check if it's correct. Because two molecules of benzoic acid are there, so we will multiply it by 2. And 15 molecules of oxygen are there, so we will multiply it by 15. Okay. So how much molar of benzoic acid is there? 244.24. And how much oxygen is there? 15 into 32, 480. So for 244.24 milligrams of benzoic acid, 480 milligrams of oxygen is required. So how much oxygen is required for 370 ppm? We will do cross multiplication. So x is equal to 370 into 480 divided by 244.24. How much we got? Into 3. We got 727.15, which is almost equal to 728 ppm. And as I have already told you, ppm is equal to milligrams per liter. Okay, so 2 of you have answered and the answer is correct. Rest of you, what happened? You got the answer or you need some more time? So the answer is 728, as you can see. Yeah. So that's all for today. Any doubt in any of the questions?
Thank you, ma'am.
Okay. So